So we're going to be looking at graphical information about functions. We said earlier that functions can be represented in a variety of different ways. We've looked at the domain of functions. We've seen some functional formulas, but those formulas can be put into graphs. And we will talk about how to take an equation and make it into a graph later on as we look at different types of functions. But for now, what we are really interested in is seeing what the graph of a function looks like. In order for a graph to be a function, or the graph of a function, it's got to pass the vertical line test. And what the vertical line test basically says is that if I take a vertical line and I run it along the course of the function, if I run it along the function's domain, the graph of the function does not touch the vertical line in more than one place anywhere. So this is called the vertical line test. So if I take a vertical line, a better vertical line than that. If I take a vertical line, any vertical line, it only intersects at one point. So I could take a straight edge, a ruler, a pencil, whatever, and I run it along the course of that function. And notice, at any given point, that vertical line is only touching the function at one point. If it had touched it more than one point, then the graph would fail the vertical line test and therefore not be the graph of a function. So this graph passes the vertical line test, and so this is a function. Again, we run that vertical line along the course of the function, and at any given point, the function is only touching that vertical line at one point. So again, this passes the vertical line test. This is a function. Take something like this. Now, it only has to fail once, but this fails at just about every point in the domain. As I go along, if I take a vertical line, then this function touches that vertical line in two different places. That is not okay, right? That means that this graph is not a function. So in order to be a function, when you run that vertical line along the course of that domain, as you run it from left to right or right to left, any vertical line cannot touch the graph at more than one point. If it does touch the graph at more than one point, not a function. So when we look at the domain and the range from a graph, we do not have the same formula. So we basically can only work with what we see. The domain, remember, that is your x, and so domain is related to your left and right, and then the range is related to your y, which is your up and down. So in order to determine the range, we look at the shape where the graph is plotted, and we do have to make some assumptions. So first the domain. How far left and right does it go? Now, any graph only has a window of what we can actually see. So if the graph goes off the edges like this one does, you can only assume that it's going to follow the same pattern as it goes on forever. So like this one, even though it stops, because at some point it has to stop, it would continue to go up and down and left and right for as long as it does. So if you have that going off the edge idea, you assume that it continues to follow the same pattern as what you can see. Such as in this case, because it's going left and right when it leaves and it's going up and down, the domain in this case is all real numbers. And the range is also all real numbers. And again, you can't see all the real numbers. all you can do is assume that this graph is going to continue on with the same pattern as is shown. So in this case, as we're looking at this, again, we assume that this is going to follow that same pattern up, but it stops right here at that 0. So as far as left and right movement goes, if I continue to go on forever that way and forever that way, my domain will be all real numbers. But the range will not be all real numbers, because as I am looking up and down, I see that I stop here at 0. So I'm going to include 0, and then I am going to go on to infinity. That tells me that my range stops or starts at 0 and then goes on forever in the positive direction. Another thing that we are always looking for in these graphs is the zeros of the graph. And this is where the graph intersects the x-axis. So in this case, if we are looking at this, and we'll have to put a little 1, 2, 3, 4, just like it has in the worksheet, right? The 0 is going to be at the point 1, 0. And that is the point where that graph actually intersects the x-axis. So a 0 is an x value that gives a y value of 0. If the graph of the function has an x-intercept at a point, then that a value of the point is called a 0 of the graph.